Only mode.
Hi everyone, thank you for joining our webinar on the PTP 670 and our new PTP solutions. With us we have our product manager for the sub-6 PTP line, Sagar Deshpande. As always, if you have any questions, please type them into the text box on the right and we'll try to get to them throughout the presentation or at a Q&A at the end. So without further ado, here's Sagar.
Hello everyone, welcome to our PTP new solutions. Today I'm really happy to introduce to you our latest product line in our point-to-point portfolio, the PTP 670. For today we're going to cover the following agenda. We're going to do a quick overview of our current PTP portfolio. We're going to focus in on the PTP 670, provide some of the feature spec. We're going to do two features in a little bit more detail, the HCMP and OTAR. Next, we're going to compare the PTP 670 versus the PTP 650 and what differences are there. After that, we're going to do a quick summary of our PTP 670 benefits. We're going to give you more on the product launch and where you can find more information going forward. So for our our PTP 6, our sub 6 PTP portfolio is a very diverse group of products that we have. So we have products ranging from the PTP 450 all the way to PTP 670, which is our latest product line. And as you see on your screen, you have the PTP 450 on the left. And as you keep going, and each of these products has a uniquely distinct feature. So example, the PTP 450i has ARQ and has ATEX and has lock capability. The PTP 650 has been a forefront runner and been there for a number of years. The PTP 650 also is one of our most prominent products, which has a lot of feature specs built into it. And our latest 670 takes our legacy product of 650 and kind of takes it forward one more step. So I want to address some of the vertical markets that the PTP 670 is more applicable towards. Today I'll be focusing more on industry, service providers, public safety, utilities, and enterprise private networks. The first one, the big one, is the wireless service providers. So these are your WISP providers who are willing to provide the 2G, 3G, 4G backhaul. They're going to be your last mile access. They can be used for, they use it for Wi-Fi offloading. Also provide temporary backhaul to for deployments, along with extended network quickly. So for example, you're in a remote rural area to provide network and services to that. These guys are the best. So the PTP 670 has a long range, which we will get to in the next few slides, where we can use this as a beneficiary to provide like a strong wireless backbone to like remote parts of the network. Next is our enterprise service providers. So for example, in sectors such as education, healthcare, hospitality, schools, college campuses, hotels, and retail stores where you want to provide internet connectivity to them, the PTP 670 has the capability and the throughput capacity to handle any of these scenarios and has already been used widely for the 650 series. Government, be it state government or central government, you have leased lines replacement which can be used. We can use it for video surveillance and extension for backhauls. They can be used for emergency preparedness and disaster recovery. So this, so our PTP 670 falls under all the regulations, has all the regulations built in so that it can support government projects as well. So for public safety, our PTP 670 is really useful for on-screen video monitoring, real-time database accessing, video surveillance, backhaul, and extension, as well as disaster preparedness and recovery. Oil and gas is one of our main vertical markets that we try to target. So one of the main applications for oil and gas companies is offshore to onshore and onshore to offshore communication, which is like the bread and butter, because a lot of these deployments are in the middle of the ocean or at really harsh conditions where you don't have direct access to internet. So having communication is one of the most vital pieces of equipment. So you also want to protect those surveillance, those products. So you have video surveillances protecting your personal assets. It also is built for network redundancy in case one of the line breaks down. And the final one is utilities, where you can use it to connect to rural connectivity networks. You can have network redundancy and disaster recovery, also have last mile fiber extensions, and also integrate it into like smart meter backhauls. You can also use it for video surveillance for utility equipment as well. All right. So the PTP 670, this is the picture. It comes in two flavors. One is the PTP 670 integrated and the PTP 670 connectorized. It is a wideband solution, so it ranges. So the radio is capable of handling from 4.9 gigahertz all the way to 6.05 gigahertz. So a little bit more in detail with respect to the 670. So we have the frequency bandwidth, as I mentioned earlier, from 4.9 to 6.05. We also have channel bandwidth that varies from 5 all the way to 45 megahertz, which we'll get in the next few slides. We have the best-in-class bits per hertz spectral efficiency of 10 bits per hertz. So this means you always get the maximum bang for your buck with respect to whatever channel size you have. Our interface is 2x2 MIMO. It has one PoE gigabit Ethernet port, which is used to power the ODU as well as get the data in. We have one auxiliary port which can be used for video surveillance as well as wireless AP. And we have one SFP port that you can use for fiber extension if you choose to. It is we have a TDM module similar to the 650, and it's an optional unit that you can have, and it is compatible with the 670. We have adaptive modulation from BPSK to 256 QAM. We have the aggregate throughput of the 670 is 450 Mbps. It has a really strong packet processing capability of more than 900,000 packets per second, and it supports jumbo frame up to a size of 9,600 bytes. The antenna gain on the integrated unit is 23 dBi, and with respect to latency, it is 1 to 3 milliseconds one way, and it has a metal housing of IP6667 ruggedness to it. So the top 5 key features of the PTP 670 is it supports point-to-point mode as well as HCMP mode, which we will get to in the next few slides. It supports DSO as the PTP 650. And we'll also get into a little bit more of the specifics of the DSO in the next few slides. It also supports IO-FTM. It supports non-line of sight applications, especially in networks where you have a lot of reflection and a lot of plane surfaces, and maybe there's a lot of trees and new development. Non-line of sight applications is really useful and powerful over there. It supports SYNC-key and 1588 timers as well. Okay, so the first one is the radio performance. The PTP 670 has a max throughput of 450 Mbps, and it has a spectral efficiency of 10 bits per hertz. It also has a line speed of 900,000 packets per second. So what does it mean is you can process a lot more packets, and given the speed of the packet processor. It has a high link budget of it has a high link budget even at 64 and 256 QAM. The channel size is actually variable, so we have channel sizes from 5, 10, 15, 20, 30, 40, and 45. So what this means is a lot of times when you deploy a 670 or any of the other radios, you are not sure what's the maximum channel bandwidth that you can get in the real world, because a lot of times there's a lot of congestion based on other radios. So the PTP 670 gives you a unique opportunity to kind of try to use the best channel bandwidth that you have given the real world scenarios. So let's say you just have 30 megahertz of channel, so you can just use the 30 megahertz to try to get the best throughput for that radio. So sometimes in some congested areas such as like Singapore and India, you might have just 5 to 10 megahertz of space because the network is so crowded. At that time also we have the capability of getting it into such finer details which you can use for getting the max throughput for your radio. So we also have fast adaptive modulation. So we have 13 levels of our modulation scheme starting from BPSK to 256 QAM. So this is useful for say you suddenly have a different, so in your environment suddenly let's say your noise level goes all the way up because of another radio or because of another interference. So our adaptive modulation takes into consideration all of this and drops it to a level so that you always try to optimize the maximum number of the maximum throughput that you can over the network. So this adaptive modulation works really fast, so you don't have to manually change, come in and just see the network is down or the link is there's low throughput speed. The 670 automatically takes care of it and tries to perform the best throughput at any given point in time. It has a low and consistent latency of 1 to 3 milliseconds. This is due to the super awesome line speed capacity. So we are able to process packets faster. So we are able to achieve this. It has a dynamic uplink and downlink ratio. So what this means is a lot of times you have different types of traffic. So a lot of times, especially if you're using enterprise, you don't know when there's going to be a lot of upload versus a lot of download, or even in video surveillances, which is more fixed, you generally have more of an upload than a download. So since due to variations in this this type of data usage, having a uplink and dynamic uplink and downlink ratio is really useful. So for example, early in the morning, you might have a lot of downloads, possibly from a lot of employees coming into office and then downloading from the from their email servers. And maybe in the afternoon, you might have a lot of uploads. Maybe people are documenting a lot of stuff, so they need to share it on their cloud. So this kind of dynamic changes on a day-to-day or hour-to-hour basis is really useful, and it helps our customers. It helps customers have almost a continuous throughput in that sense. So providing a different ratio of uplink to downlink, which I'll go into a little bit more detail in the near future, is a really good example of understanding customer needs and kind of catering to it as well. So we do have a non-line of sight and near line of sight. So this we'll also get into it in one of the other upcoming slides. And as I mentioned earlier, we support up to 256 QAM. So this is our flexible channel size. So as I mentioned earlier, so we have all the way from 5 megahertz to 45 megahertz. So it covers a wide range of channel bandwidth. So based on your deployment, if it's in rural areas or if it's in urban deployments or if it is next to like a cell tower where you already have congestion, especially in the 5 gig band, the PTP 670 is really useful because you can correctly choose which channel, the maximum channel size that you can use without avoiding interference, which as you know leads to lower throughput. So you can always try to get the maximum bandwidth that you can, maximum throughput you can based on choosing the right bandwidth. So the PTP 670 is highly reliable. So I'm going to focus a little bit on DSO. So DSO is mainly used for, stands for dynamic spectral optimization. So consider you have as you know, if you deploy any radio in the real world, you have a lot of interference. So the interference could be transient because of birds flying by or like trees moving around, or it could be based on the rising noise flow because of other radios in the sector, or it could be new installation of a radio right opposite to your radio just blocking and then just interfering by using the same frequency channel. So what DSO does is it dynamically scans for the spectrum. It scans for the entire spectrum from 4.9 to the 6 gigahertz spectrum, and then tries to and gives you analytics of what is actually going on, and then you have the ability to choose or to jump to another channel. We'll get into it a little bit later on, and we have a few slides to explain it in more detail, but this is just to give you an overall perspective. So we do support TDD sync. So TDD sync is basically useful if you have co-located radios and you're trying to use the same frequency, or you want to try to reuse the same frequency. So for example, you want to, so then what you do is when you have a frame, you try to use the uplink and downlink, and then you try to sync the uplink and downlink duty cycles so that all your radios in one located channel are transmitting at one time, and then all of them are receiving at the same time. So this avoids interference that goes on due to multiple radios in your cell tower. So say for example, you've deployed maybe 1 or 2, and then you increase your capacity by adding more number of people. So when you add like 3 or 4 radio towers, there's a lot of interference that happens based on the same radios itself. So having a synced, so this is an option. This is an option that is available. So having it synced definitely minimizes the interference that happens. So we also have a split frequency operation of TX and RX. So basically what this means is you can use different frequencies for uplink and downlink. So if you think about it, when would this be useful? So let's say you are already deployed in a network where you don't have any, so you want want to deploy it in 2 points, but then there's no common channel bandwidth that you can use, which is free on both ends. So let's say you have a 5.1 free on one at tower A and then 5.8 free on tower B. So there's no common channel that you can use to get like the maximum throughput. So what this split frequency operation helps you do is you can use 5.1 to transmit from A to B and use 5.8 to transmit from B to A, and then reverse the receive cycle part of it, so that you can use different frequencies to try to gain maximum channel throughput. We also have the 670 is Link Planner capable. So Link Planner is our online is our software tool, which is highly recommended, and it's one of the best RF planners out there in the market, and it's free. So we use this a lot of engineers use this to plan out their networks. It's synced with Google Earth, so you get real-time information on the you get updated information on the landscape and how the radio is going to perform in the real world, along with Fresnel zone and interference and all those fun stuff that you can add in to simulate a real world scenario and situation. We have a fast adaptive modulation, which I kind of spoke about earlier. That's due to changing of adaptive modulation from 64 QAM to 16 QAM based on noise, or maybe increasing it once the noise kind of fades away. So the PTP 670 is IP6667, which has a metal housing built in. So it has a long history of. So our PTP 650 comes from a long line of service, and it has been deployed for more than 5 billion hours combined. And then it has a mean time of failure of more than at least 40 years. So we have used a similar housing for the 670, and we expect the same results in that sense. So the radio also is capable of handling like harsh conditions from -40 degrees to +60 degrees. So okay, so to talk a little bit about DSO, so the slide that I'm presenting now kind of is a snippet on our on one of the radios. It's one of the sections that you can get into, and it kind of shows which channels that you're using. Is each of the bars slab is 10 megahertz, 5 megahertz channel, and each of the blue ones represents the noise flow that you have. So on the left hand side, you can see the noise level or the power level, and you can kind of see what channels you would want to be when you're transmitting or receiving. There's also options for you to block a particular channel if you wish to, so that when you're searching for new channels, you would want to avoid the channels that you've already blocked. So an example of this would be, so let's say you want to use it for if you want to use it for interference that is already happening. So what you can do is you can set the noise flow level, so that once it crosses a threshold, you would want to move to another channel or another bandwidth size. So another advantage of this would be you always have a real-time analysis of the spectrum of the real-time analysis of the spectrum at any given point in time. So for example, if you want to know, like at this point, because we do keep a running 20-minute timer of the latest updates of the network scenario, it's really important for you guys to figure out what was or what is the current radio interference look like, and would it make sense for us to move to another channel as well. So this would be our GUI. So if you buy a radio and then log in, if you go to Systems and Spectrum Export, you find this chart. This is a really useful chart. On this chart, we have a 4.9 all the way to 6.05. So the entire spectrum is shown over here. So if you have a regular radio deployed in a particular location, you can see from the diagram, you can see the 5.7 to 5.8 gigahertz spectrum is highly utilize, and maybe that's not the right space for us to deploy. That's not the right channel or for us to use this. So based on this, you get a real-time analysis of what would be the next best channel to move to. So you can also have historical analysis, which kind of goes into the mean aggregate over a configurable period of time that you can do. Also, the DSO is almost hitless, which means you don't drop any packets, you just automatically move to the new channel without losing any packets. So you can configure it to move quickly, or you can take your time and kind of focus in on, okay, I need to move every 20 minutes, or revisit the option of moving to every 20 minutes, or you can choose to move it even quicker if you feel more efficient. So all this data that you collect, all this information is available in GUI, and you can always export it out for your for more analytical approach towards RF planning. Next one I want to focus on is the non-line of sight and near line of sight. So the PTP 670 is capable of a max line of sight range of up to 155 miles. So this is with respect to with respect to avoiding the Fresnel zone distance. So when you have a near line of sight which covers half or 1/3 of the Fresnel zone, then you get into something called near line of sight. So which is where like maybe trees come in the way and the entire spectrum cannot be transferred. So there's a loss of there's some interference which helps which results in loss of which results in drop of throughput. So in this case, for near line of sight, it goes up to a maximum of 25 miles. And for non-line of sight, which means basically you cannot see the other side, we try to use reflection, and we try to solve it through reflection and diffraction using HNV polarization if we want, and then you can use those parameters for you to get non-line of sight of up to 6 miles as well. This was so I want to focus a little bit on the uplink and downlink symmetry. So this is really useful, as I mentioned earlier. So you have a enterprise system which has an irregular uplink and downlink ratio scheme. So maybe in the morning there's a lot of downloads of emails and other stuff, and maybe in the afternoon there's a lot of uploads of documents to the main headquarters. So in this case, if you want to use symmetry, which is 1:1, so you have allocated 225 Mbps downlink and then 225 Mbps uplink. So this is not fixed, it's variable. So you can configure it to 2:1 or 1:2. You can configure it to 3:1 and 1:3. You can configure it to 5:1, so which means 375 is downlink and then just 75 is uplink. Or you can just set it to adaptive mode, which automatically takes care of all this, and then it automatically does all the uplink and downlink ratios for you, given the traffic load as well. So the 670 is it's one of the best products out there with the maximum security built into it. So it has a 128-bit AES key encryption. It has a 256-bit encryption. It has multi-level user authentication, which is really important, especially if you want to control the RF radios, as well as allow some people to kind of use some aspects of it. So it's really useful in that scenario. You want to have it also has radius authentication. It also has out-of-band management, so you can log in from an outside network. And also we have a new feature called OTAR, over the air rekeying, which we'll get into a little bit. So basically that allows you to change your password key over the air, so you don't have to manually do it for every single radio every time. So now I want to focus a little bit on our HCMP. So HCMP stands for high capacity multi-point. So in this, basically a good illustration would be this scenario that we have. Say you want to connect 4 links to 4 nodes. So one master to one node, and each node wants to use, let's say, 4 cameras for itself. So, so one way would be to deploy 4 point-to-point links from one master tower to 4 nodes in different areas. Or it would be much cheaper and easier to deploy just one HCMP master that controls up to 8. In this case, we have shown 4, but we can support up to 8 nodes easily. So when you move from configuration of PTP to configuration of HCMP, what you're basically doing is you're taking the bandwidth of 450 Mbps and you're splitting it evenly or unevenly between the different nodes. So for example, if you have a typical example would be if you have 4 nodes, the maximum Mbps per node is around 80, and if you have 8 nodes, the maximum the maximum throughput per Mbps would be around 42. So we time slot each of the nodes. So we use that for uplink and downlink purposes as well. So you can kind of time slot. So you always have dedicated bandwidth for each of the nodes, and it's not like contention based. It's not a contention based approach where it just depends on who gets to go first. It's ordered. So using this way of deploying, you definitely use fewer radios. You definitely lesser the tower load because you don't need to have multiple master nodes enabled. You definitely use lesser power because you're just powering one. fewer antennas on the tower as well as simplified alignment, because the HCMP, once you align it in a particular direction with the sector antenna, you can support up to 8 nodes. This would be a typical deployment of a HCMP. So we have, so this would be a building to street approach. You can use it for a building to building as well as a street to street, but this kind of illustrates how you would use a HCMP. So say you have a HCMP tower in HCMP radio, which is marked in red on top of a building, and then you have 3 street deployments which cover maybe a video surveillance of a particular building in a particular location. So you can have all the 3 links connected to a HCMP master, and maybe you can run a wire all the way back to the PTP 670 that's mentioned to the end of the building, and then you can use that to put it back to headquarters or to any of the other, to mainly backhaul it to your network. So this would be a good example of how you want to use a HCMP scenario where you want to deploy 3 or maybe more than 3 towers, keeping very high throughput. So in this case of 3 towers, the max throughput would be around 106 or 107 Mbps per node itself. So now I'm going to focus a little bit on OTAR. So what is OTAR? So OTAR is actually a secret key that's used to encrypt over-the-air data, and it's automatically generated, and it automatically negotiates and seamlessly applies to pre-configured intervals. So you're already changing your password on a regular basis automatically without any user intervention. Rather than, so what are the advantages? So you don't need any person manually to write up or to change a password every 15 days or 10 days or 3 months. It's a simplified and streamlined operation which virtually eliminates all risk of compromise. So you don't give all access to one person or one entity to change all the passwords. So it's automatically logged. It's done automatically. So you don't have to keep an eye out or just always be worried that someone might steal your information. It also fulfills the corporate requirement of security for the customers as well as for the radio deployers. So for example, you have regular key updates, that's definitely useful to help to ease the pain of customers who are worried about security. So one of the main benefits is you save a lot of man-hours in manually updating the network with the latest security patch, which helps customers that have already been affected by the latest cyber attacks. As you know, cyber attacks are happening and it's not going to stop anytime soon. So the best thing that we can do is try to automate and try to keep up with all the latest attacks. And one of the ways that we can achieve this is by OTAR. So by manually changing or by automatically changing the key every so often, that would be our next best effort to keep these type of attacks away. So now I'm going to focus a little bit on the comparison between the 670 and 650. So if you compare just pure radio performance, the PTP 670 is really similar to the PTP 650. If you compare the price, the PTP 670 has, with respect to variants like connectorized and integrated, is the same price as the PTP 650. The antenna size is slightly different. So the PTP 670, we have tried to reduce the antenna size from 14 by 14 inches for the 650 to 12 by 12 inches while maintaining the 23 dBi gain that we have. Another advantage for the 670 is the HCMP approach. So you can use it for point-to-few points deployment for PTP 670, which is not capable for the PTP 650 as well. So the variations for the hardware, so the PTP 650 would come in the 650, 650S, 650L, the connectorized and integrated, whereas the 670 just comes in integrated and connectorized version. So with respect to brackets, we have changed the brackets slightly for better performance. So the new brackets that we're using is much more sturdier. So this is definitely in line with our motto of improving all aspects of our radio. So quick highlight of quick takeaways of what are our 670 benefits. One, we have a faster processor with more memory, so you can expect more exciting features in our roadmap in the coming future. It is HCMP compatible, so the HCMP, even though it's time shared, the spectral efficiency is around 9 bits per hertz, which is pretty high, and it connects up to 8 remote nodes. It has OTAR support and a OTAR capability, which is really used for security purposes. And it has a simplified licensing structure, which means the 670 comes with full capacity key, full capacity built in out of the box. So you don't have to pay for a separate license key, just how you would have for the 650. So this 670 comes with the full capacity out of the box. And another final really good advantage is backward compatibility with the 650. Say you already have a network deployed with the 650s and your worried is how will my 670 be compatible with the 650 given my deployment of such a vast network. So the answer is yes. So for the 670, we do have a special firmware that we are going to release in Q4 of this year, which is going to ensure the PTP 670 to behave exactly as the PTP 650. Right, so this is one thing that you have definitely considered, and we feel it's really valuable for our customers who have already deployed a 650 and are really happy with its performance. Also, all the 650 accessories are going to be compatible with the 670, so that also helps the customers in reusing whatever they have and try to save, try to reuse any of the 650 radios, or if you want to buy spares, you can kind of reuse the older ones that you already have. With respect to pricing, just to highlight from before, we have the same hardware pricing of the radio as the 650, and there is no license key for full capacity key, which means the radio automatically comes with the full capacity key. So a little bit of our product launch. So our product has launched on June 21st, which is yesterday, and we are taking a lot of orders in. If you want more information, you can please contact us on cambiumnetworks.com for further information. And for more information, you can go to our website. We have the cambium.com/product/backhaul that provides more information. We have a lot of spec sheets and white papers to kind of complement and kind of develop more understanding of the PTP 670 and more attributes that it possesses. So we can also, please check out our community forum as well. So we post questions regularly based on different products with respect to installation, knowledge base, newbie introduction. So especially if people are coming up to speed with different product lines. So we have a lot of information with respect to coming up to speed for especially new employees who have joined the network as well. So for any other information, please contact our community Cambium network page, and we look forward to interacting with you.
All right, thank you, Sagar. And here's Alan. Also on the conference, on this bridge, we have Anthony Jamin, who is our technical lead on this project for PTP 670. So, we're happy to answer, different questions you have. So I think, as Sagar said, 670 is a new product we just released. And this is really a new generation or a new update, based on our legacy from old days on the PTP 400, PTP 500, PTP 600. We moved to 650. Now we move to 670. So it has all the legacy features or functions our customer like. So high capacity, high spectrum efficiency. ECM, very robust to support the not line of sight applications. And in addition, we talk about the HCMP, the high capacity multi-point. This is a great thing we added on the PTP 670. So one thing I want to ask Jamin to help us get a little more on HCMP is Anthony, can you tell us a little more about how HCMP compare with a general, say, a point-to-point system? What is the benefit on HCMP on PTP 670?
So the main benefit of HCMP compared to a traditional point-to-multipoint system is HCMP is designed to be multiple point-to-point link or equivalent to. So we are not trying to look to have a number of subscribers like you have in a traditional point-to-multipoint with like few tens or hundreds as we do in our 450 portfolio, for instance. In that case, we're trying to have a small number, up to 8, 8 links which have the same characteristics as the PTP links. So we divide the bandwidth between 8, but we are trying to keep the low latency and a dedicated throughput for each of the link. So there's no contention. In the traditional point-to-multipoint, you'll have contention on all the bandwidth of the link capacity is all the users are contending for accessing the bandwidth. In HCMP, each link has dedicated bandwidth. So effectively, as we will have in a point-to-point. That's, I think, the main differentiation between HCMP and traditional point-to-multipoint.
So basically, we can treat, like in your example, if we have 8 remote, literally every link will be an independent point-to-point link, and they will have their own throughput guaranteed and have a pretty much good latency as well, rather than like the PMP, they're fighting to each other, and you don't have that kind of like guarantee, right?
That's exactly correct. Yes.
And I think this, when we talk about this one, you know, at the end customer, you can see is specifically in certain applications for enterprise or for backhaul for video surveillance, you do want to give certain, you know, warranty or guarantee there for the capacity or latency, and this will be a very good features to be used to support such applications. Another question we have on the panel right now, HCMP related, is can they using 650 mixed with 670 for HCMP?
Unfortunately not, and one of the key part of PTP 670 was to upgrade the platform in terms of processing power on the 670 as a double the capacity of in processing power and double the DRAM as opposed to the 650, and one of the main motivation for this upgrade was actually to support HCMP. So unfortunately the 650 doesn't have the processing power to be supporting HCMP. Thank you.
So the other question is, if I do have a 650 network, and I think we mentioned about 670 backward compatible, can you talk a little bit more about how this backward compatible really means?
So in order to support backward compatibility when the 650 in existing 650 networks, and on the case we want to have a 670 operating in the same network, we will have a specific software release, a firmware release coming on the 670 to make that compatible. So that will be a specific firmware which will allow compatibility, which will be different from the latest 670, which will have other features on HCMP and so on, which are not compatible to 650. So that particular firmware on the 670 will make it compatible to 650, basically emulate the 650. So you could carry on buying 670 and using them on the 650 network.
Thank you. So for the, I think for the people online, so we talk about a special firmware. Once you load this special firmware on 670, it will work like a 650. And this firmware will be available in later Q3. And we will publish this one on our support webpage. You can download if you want to do that. I think this covers question from David and Alan. And the other question we have is, since we talk about HCMP, obviously your AP need to have a sector antenna. Is there what is the, can you talk a little more about this sector antenna?
Yeah, sure. We have a number of sector antennas available already, and the easiest way to see them will be to use link planner. But specifically for HCMP, we are coming out with a connectorized version of an antenna. The Cambium antenna, which has been specifically designed for that application, and that's coming out in a month, I believe, in a month or so, and that's covered the whole frequency range from 492 to 605.
Okay, good. So let's talk about a little bit more things in the 670. So with the 670, we start support the Cambium Sync with CMM5 and other stuff. Can you share a little bit more about what is the sync capability of 670 and what kind of sync resource can be worked on with PTP 670?
So the 670 has the same capability as the 650 to start with. So it's supporting the PTP sync, all the PTP sync configuration, and we had on 650 are supported on the 670. So that's existing one legacy option. That's the first part. The second part we will introduce on the 670 is what we refer to as a Cambium sync. The Cambium sync is a new method which we can use for synchronization of a multiple quality radio together with an injector on power supply, which is the CMM5. The CMM5 allows to power up to 4 units and synchronize them all at the same time. So instead of having at the bottom of the mast 4 power supply and 4 PTP sync injectors, we interconnected. You now have only one CMM5 which will provide the power or all synchronization to all 4 units.
Right. I have a question for Sagar here on the pricing side. What is the 670 price compared with 650?
So the 670 price, the radio price is the same as the 650. So all the so for example, the 650 connectorized price is the same price as the 670 connectorized price, and the 650 integrated price is the same as the 670 integrated price. The only advantage, or the main advantage, that the 670 has is you don't need to buy a special the license key to upgrade to full capacity key. The 670 automatically comes with the full capacity built in out of the box, so you don't have to purchase that aspect of it.
Okay, thank you. I have another question here. I think it's related to the OTAR. So OTAR is over-the-air rekey. This is a feature actually it's a new feature introduced on 670, and the big benefit is to improve the security. And people's asking, is this they have some experience on this one? I'm not sure on maybe on the 700 platform. They talk about sometimes they don't know if it will cause any link job or how this really works. So Anthony, do you want to give us some summary on how OTAR works, and do they need customer pay more attention to do the configuration, or how customers should take care of this?
Yeah, sure. So on the OTAR, we have introduced a set of security features. Part of the OTAR features is we're using internal security certificate within the units. That allows to the unit to be, which has been embedded at manufacturing and has been certified by Cambium. So that's allowed to authenticate the unit. So without adding any generated key from the customer by yourself, you can already rely on that certificate to say, oh, that unit is actually who they say they are. It's not somebody else who bought another Cambium unit and trying to connect to my network. So that's the first part. Now we use that certificate in OTAR to, when the link is established, so to unit exchange the certificate, and they verify that the other end say are who they say they are. If that's the case, and they've been allowed to connect by configuration, they exchange their own encryption key. Seamlessly, they negotiate the key and exchange between both ends, and starts as encrypting all the traffic. So no user traffic is passed unencrypted. Only traffic which is not at risk. So as soon as the radio connect, they encrypt the data automatically, and with OTAR, with automatic rekeying, we can set an interval, say every hour, every 24 hours, every 30 days, 60 days. We negotiate a key. So there's a lot of corporate policies now. We require encryption over the air to be regularly updated. In many cases, that will include if you don't have a secure way to communicate from one end to the other, that will mean going on site and change the key manually and restart the radio. Now. The exchange of key is totally seamless, so no throughputs, there's no loss in throughput, there's no errors, there's no interruption of the link. It's all happening on the hood without any effect on the traffic, and it's not visible by the operator or by way of using the link.
Right. So this is critical for government or utility customers, key critical infrastructure customers. Because either by their own security concern or by certain government regulatory, you need to change your encryption key periodically to avoid, hacking or, other things. So with the OTAR, then you can set up how frequently you change the key, but the link is not interrupt. It's totally transparent. You don't feel anything, and there is no link job things. Back in the 650 days, when if you want to rechange the AES encryption key, the radio will have a short outage because it has to be reset to re-implement the key. So this OTAR thing really helps for the customer from those key critical infrastructure customers, and this gives them a big benefit to improve their security using this feature. And so question for Sagar, is this OTAR a standard feature for 670?
No, the OTAR is not a standard feature. You have to buy the option key, the license key for it to be upgraded. So this is per radio. So you have to buy it for each radio to enable it on that.
Okay, so I have to buy 2 keys for a link.
Right, that's right.
Since we talk about license key, we know the 670 gives the full capacity out of factory from day one. We also talk about HCMP. Do I have to pay license key for HCMP?
Yes, but the advantage of this is you only need to pay to enable 670 to become a master. You don't have to pay for other nodes that are connected to it. So let's say in our example deployment where we have 1 HCMP master and 4 nodes, you just need to pay for 1 license to upgrade the 670 to the master level. You don't have to pay for other nodes to so the other nodes can behave as they are.
So you're saying is I just need to buy a single key for the AP side.
That's right.
And there's no other key required from remote side.
Right.
Okay, thank you. So I look at other questions online. So there's, I think there's a question talk about the time sync. So if I have an existing 650 network, I'm using GPS sync to do the TDD sync for my network. When I add new 670 into the system, how I can embed 670 into my system and run the TDD sync with my existing 650. Anthony, you want to address this question?
Yes, so in terms of whichever method of synchronization we use and whichever product you use, the synchronization will be equivalent. So you could have a mixed network of 670 or 650 using PTP sync. You can introduce on the same network 670 using either PTP sync, either HCMP or Cambium sync. The synchronization is effectively equivalent. So whichever method you use or whichever product you use, they will be all synchronized properly.
Right, thank you. I was told the CMM5 can also do the PoE for the radio. Is that available for 670 as well?
Yes, you can power up to, CMM5 can power on synchronize up to 4 units at the same time.
Right, so I think for the customer who buy the CMM5, it's not only give you the sync in source, but also you can use the PoE capability to power your radio.
Yeah.
Thank you. So for our audience, any other questions you have, please, post on the panel, and I think we're getting to the. Actually, we're running out for the questions. I have one more question here. Do you mind? Do you mind tell us why the PTP radio is very good for the have a best performance in the industry for not line of sight applications? Why you can do this?
Essentially, then per design, non-line of sight was always been a configuration that has been supported by the PTP product, and we're using OFDM configuration, which is specifically optimized for non-line of sight configuration. And the OFDM is modulation is very good at dealing with multipass, as you have when you have a non-line of sight. The A mode is also very fast at responding to a change of configuration, which you have when you have non-line of sight on the reflection are moving, either going through trees or vehicle moving around. So that's making the channel moving very quickly. But the PTP products have been optimized for that kind of operating condition.
Okay, thank you. I think that's all the questions we have received so far. Colleen, back to you.
Yeah, and if you guys think of any questions later, definitely ask them on the community where this session will be posted, and we should be able to also get the slides as a PDF version and post them there as well. So we check the community. Each product manager is designated to check it for about half an hour a day. So you could either get your questions answered by other real Cambium owners or an official Cambium employee in a timely manner. So yeah, and that's my little spiel right there. So looks like there's still no more last minute questions. So thank you everyone for joining. Thanks for the great presentation, guys, and thank you for your time.
Thank you.
Thank you.